Interactions between celestial bodies. The interaction between celestial bodies is a fascinating topic that has captured the imagination of humans for centuries. From the movements of the planets in our solar system to the collisions of galaxies, the dynamics of celestial bodies are complex and beautiful. At the heart of these interactions is the force of gravity. Gravity is the force that attracts two objects with mass towards each other. The strength of this force depends on the masses of the objects and the distance between them. The greater the mass of the objects and the closer they are to each other, the stronger the force of gravity. In our solar system, the interaction between celestial bodies is dominated by the gravitational pull of the Sun. The planets orbit the Sun in elliptical paths, with their speed and distance from the Sun determined by the strength of the gravitational force between them. The gravitational force of the Sun also affects other objects in the solar system, such as comets and asteroids, which can be pulled into different orbits or even ejected from the solar system altogether. Beyond our solar system, the interaction between celestial bodies becomes even more complex. Galaxies, for example, are collections of stars and other objects that are held together by the force of gravity. The gravitational force between galaxies can cause them to merge, creating new and larger galaxies. These interactions can also trigger the formation of new stars and planets within the galaxies. The study of the interaction between celestial bodies is an important field of research in astronomy. By understanding how objects in the universe move and interact with each other, astronomers can learn more about the history and evolution of the cosmos. They can also make predictions about the future movements of celestial bodies, such as the potential collisions between galaxies. In recent years, advances in technology have allowed astronomers to observe and study these interactions in greater detail than ever before. Telescopes and other instruments can detect the gravitational waves produced by the movement of celestial bodies, providing insight into the nature of these interactions. Electromagnetic forces, for example, can cause charged particles to be attracted or repelled from each other. This can lead to the formation of magnetic fields around celestial objects, which can influence their movement and behavior. Radiation pressure, on the other hand, occurs when photons of light exert a force on objects. This can cause objects to be pushed in a certain direction, and can even lead to the formation of tails on comets. The interaction between celestial bodies can also have significant impacts on life on Earth. For example, the gravitational pull of the Moon causes the tides in our oceans to rise and fall. This can have important ecological effects, such as influencing the behavior of marine animals and affecting the distribution of nutrients in the ocean. In addition, the interaction between celestial bodies can have important implications for space exploration and astronomy. For example, astronomers use the gravitational pull of planets to slingshot spacecraft to other parts of the solar system, allowing them to explore distant objects such as asteroids and comets. For example, astronomers use the gravitational pull of planets to slingshot spacecraft to other parts of the solar system, allowing them to explore distant objects such as asteroids and comets. One of the most fascinating aspects of the interaction between celestial bodies is the phenomenon of gravitational waves. These are ripples in the fabric of spacetime that are produced by the movement of massive objects, such as black holes or neutron stars. When these objects move or collide, they create waves that propagate through space and time, carrying information about the nature of the objects themselves. Gravitational waves were first predicted by Albert Einstein in his theory of general relativity, but it wasn't until 2015 that they were directly detected for the first time. Since then, many more detections have been made, providing astronomers with a powerful new tool for studying the universe. Gravitational waves can tell us a great deal about the objects that produce them. For example, by analyzing the frequency and amplitude of the waves, astronomers can determine the masses and distances of the objects that created them. This information can help us understand how black holes and other massive objects form and evolve over time. The study of the interaction between celestial bodies is also important for understanding the potential dangers posed by objects in space. For example, asteroids and comets can collide with Earth, causing catastrophic damage. By tracking the movements of these objects and studying their interactions with other celestial bodies, astronomers can better predict and prepare for such events. In addition, the interaction between celestial bodies has important implications for the search for life beyond Earth. For example, the gravitational interactions between moons and planets can lead to the formation of subsurface oceans, which may be potential habitats for life. By studying these interactions, we can better understand where to search for life in our own solar system and beyond. The study of these large-scale structures is an important area of research in astronomy, as it can provide insight into the nature of dark matter and dark energy, which are thought to make up the majority of the matter and energy in the universe. By studying the distribution of matter and energy on these large scales, astronomers can test theories of cosmology and gain a better understanding of the evolution of the universe as a whole. By studying the distribution of matter and energy on these large scales, astronomers can test theories of cosmology and gain a better understanding of the evolution of the universe as a whole. The interaction between celestial bodies can also have important implications for the habitability of planets. For example, the gravitational pull of Jupiter helps to protect Earth from potentially dangerous asteroids and comets, by deflecting them away from Earth's orbit. In addition, the interaction between the Sun and Earth's magnetic field can cause the aurora borealis and aurora australis, which are beautiful displays of light in the polar regions. Finally, the study of the interaction between celestial bodies is also important for technological applications, such as satellite navigation and communication. By understanding the movements and behaviors of objects in space, engineers can design and operate satellites more effectively, improving our ability to communicate and navigate on Earth. Another interesting aspect of the interaction between celestial bodies is the way that it shapes the formation and evolution of planetary systems. Planetary systems are formed through the gravitational interactions between large clouds of gas and dust, which collapse and condense to form stars and planets. The gravitational interactions between these objects can also cause the orbits of the planets to change over time, leading to the formation of different types of planetary systems. The gravitational interactions between these objects can also cause the orbits of the planets to change over time, leading to the formation of different types of planetary systems. For example, some planetary systems are highly compact, with planets orbiting very close to their parent star. The combination of physics and chemistry in astronomy. The combination of physics and chemistry is essential for understanding many aspects of astronomy, from the formation of stars and planets to the composition of galaxies and the universe as a whole. In this article, we will explore some of the ways in which these two fields of science intersect in the study of astronomy. At the heart of the interaction between physics and chemistry in astronomy is the study of the properties and behavior of matter. Physics provides the fundamental laws that govern the behavior of matter, such as the laws of thermodynamics, electromagnetism, and gravity. Chemistry, on the other hand, provides insight into the structure and behavior of molecules, which are the building blocks of matter. One area where the combination of physics and chemistry is particularly important in astronomy is in the study of the formation of stars and planets. Stars form through the gravitational collapse of clouds of gas and dust, while planets form through the accretion of smaller bodies such as asteroids and comets. The physical laws that govern the behavior of matter, such as the laws of gravity and thermodynamics, play a key role in these processes. Chemistry is also important in the study of star and planet formation, as it provides insight into the chemical composition of the gas and dust clouds that form these objects. By studying the chemical composition of these clouds, astronomers can better understand the processes that lead to the formation of stars and planets, as well as the distribution of elements in the universe. Another area where the combination of physics and chemistry is important in astronomy is in the study of the composition of galaxies and the universe as a whole. By studying the light emitted by objects in the universe, astronomers can determine their chemical composition, as different elements emit and absorb light at different wavelengths. The study of the chemical composition of galaxies and the universe can provide insight into the processes that have shaped their evolution over time. For example, the abundance of heavy elements in galaxies can provide clues about the frequency of supernova explosions, which are responsible for producing these elements. In addition, the combination of physics and chemistry is important for studying the behavior of matter under extreme conditions, such as in the cores of stars or in the aftermath of supernova explosions. By studying the behavior of matter under these conditions, astronomers can gain insight into the fundamental laws that govern the behavior of matter. For example, the study of the atmospheres of exoplanets has revealed the presence of molecules such as water, methane, and carbon dioxide, which are thought to be important for the formation and sustenance of life. By studying the behavior of these molecules under different conditions, astronomers can better understand the potential habitability of these planets. The combination of physics and chemistry is also important in the study of the behavior of matter in extreme environments, such as the interiors of neutron stars and black holes. By studying the behavior of matter under these conditions, physicists can gain insight into the fundamental laws that govern the behavior of matter, as well as the nature of dark matter and dark energy. In addition, the combination of physics and chemistry is important for the study of the evolution of the universe as a whole. By studying the behavior of matter under different conditions, astronomers can better understand how the universe has evolved over time. From the formation of the first galaxies to the present-day distribution of matter and energy. Finally, the combination of physics and chemistry is important for technological applications in astronomy, such as the development of new telescopes and instruments. Finally, the combination of physics and chemistry is important for technological applications in astronomy, such as the development of new telescopes and instruments. By understanding the behavior of light and other forms of radiation, as well as the properties of materials used in telescope construction, engineers can design and build more advanced and powerful instruments for studying the universe. In addition, the combination of physics and chemistry is important for understanding the properties of cosmic rays, which are high-energy particles that originate from sources such as supernova explosions and black holes. By studying the behavior of these particles, physicists can gain insight into the fundamental laws that govern the behavior of matter and energy, as well as the structure and evolution of the universe. The study of the interaction between physics and chemistry in astronomy is also important for understanding the origins and evolution of life in the universe. By studying the chemical composition of objects such as comets and asteroids, astronomers and chemists can gain insight into the chemical processes that led to the formation of life on Earth. Furthermore, the study of the interaction between physics and chemistry in astronomy is important for developing models and simulations of the universe. By combining the laws of physics and chemistry with observations of the universe, astronomers can create computer simulations that provide insight into the evolution of the universe and the behavior of matter and energy on large scales. Finally, the combination of physics and chemistry is important for developing new technologies for studying the universe. By understanding the behavior of light and other forms of radiation, as well as the properties of materials used in telescope construction, engineers can design and build more advanced and powerful instruments for studying the cosmos. The interstellar medium is composed of a mixture of gases, including hydrogen, helium, and trace amounts of heavier elements. By studying the chemical composition of this gas, astronomers can gain insight into the processes that produce these elements, such as the fusion reactions that occur within stars and the explosive events that occurred during supernova explosions. In addition, the interstellar medium is also composed of dust particles, which are produced by the destruction of stars and other astronomical objects. These dust particles can absorb and scatter light, affecting the appearance of objects in space and providing clues about their composition. By studying the properties of interstellar dust, astronomers can gain insight into the processes that produce and destroy these particles, as well as the role they play in the formation of new stars and planetary systems. The combination of physics and chemistry is also important in the study of the dynamics of galaxies and galaxy clusters. By studying the behavior of matter under the influence of gravity, astronomers can gain insight into the structure and evolution of these large-scale structures. By combining observations of the distribution of matter with computer simulations, astronomers can create models of the universe that provide insight into its evolution over time. Finally, the combination of physics and chemistry is important for the search for life beyond Earth. By studying the properties of exoplanets, astronomers can gain insight into the potential habitability of these worlds. By combining observations with models of planetary atmospheres and the behavior of molecules under different conditions, astronomers can better understand the conditions necessary for the formation and sustenance of life. Chemistry is also important in the study of planetary systems, as it provides insight into the chemical composition of the materials that form planets and other objects in the solar system. Different star species. Stars are one of the most fascinating and important objects in the universe. They come in a range of sizes, colors, and temperatures, and each type of star has its own unique properties and characteristics. In this article, we will explore the different types of stars and the roles they play in the universe. The most common type of star is the main sequence star. These stars are in a stable phase of their life cycle, fusing hydrogen into helium in their cores. The size and color of a main sequence star depend on its mass, with more massive stars being hotter and brighter than their lower mass counterparts. Another type of star is the red giant. These stars are nearing the end of their lives and have exhausted the hydrogen in their cores. As a result, they begin to expand and cool, becoming much larger and redder in color. Red giants are important because they are responsible for the production and distribution of heavier elements, such as carbon and oxygen, throughout the universe. White dwarfs are another type of star. These stars are the remnants of low-mass stars that have exhausted their nuclear fuel and have collapsed to a very small size. They are extremely hot and dense, and they emit a high amount of ultraviolet radiation. Neutron stars are the remnants of massive stars that have exploded as supernovae. They are extremely dense, with a mass comparable to that of the Sun but a size on the order of a city. They emit radiation across the entire electromagnetic spectrum and are important for studying the behavior of matter under extreme conditions. Black holes are the most exotic type of star. They are formed when massive stars collapse under their own gravity, creating a region of space where the gravitational force is so strong that nothing, not even light, can escape. Black holes are important for studying the behavior of gravity and the structure of spacetime. In addition to these types of stars, there are also many other exotic and rare types, such as blue giants, Wolf-Rayet stars, and pulsars. Each type of star has its own unique properties and characteristics, and they all play important roles in shaping the universe we see today. Stars are not only fascinating objects to study, but they also play crucial roles in the universe. For example, it is believed that stars are responsible for the formation of planets and the development of life. Without stars, the universe would be a very different place. One of the most important roles of stars is the production of energy. Stars generate energy through nuclear fusion, which occurs when atomic nuclei are fused together to form heavier elements. This process releases a tremendous amount of energy in the form of light and heat, which is what we see when we look at stars in the night sky. Stars are also responsible for the production and distribution of elements throughout the universe. When stars fuse atomic nuclei together, they create new elements, including helium, carbon, oxygen, and iron. These elements are then distributed throughout the universe when the stars eventually die and explode as supernovae. Another important role of stars is the creation of planetary systems. Planets are formed from the debris left over after the formation of a star. As the gas and dust in a protoplanetary disk spiral inward towards the center, it begins to clump together and form solid objects, which eventually grow into planets. Stars also play a crucial role in the development of life. It is believed that life as we know it could not exist without the energy provided by stars. The light and heat from stars provide the energy needed for photosynthesis, the process by which plants convert sunlight into food. This process is the basis of the food chain, which ultimately supports all life on Earth. In addition to their important roles in the universe, stars are also objects of great beauty and wonder. The night sky is filled with stars of different colors and sizes, each with its own unique story to tell. By studying these stars, astronomers can gain insight into the processes that shape the universe and the behavior of matter and energy under extreme conditions. Stars are not only important for their scientific value, but they also have cultural and historical significance. Throughout human history, stars have played a central role in myths, religions, and art. Many ancient cultures believed that the stars were the souls of the dead or the homes of the gods. The ancient Egyptians, for example, believed that the god Osiris lived in the constellation Orion, while the Greeks believed that the goddess Athena lived in the constellation Ursa Major. In addition to their religious significance, stars have also been used for navigation and timekeeping. The position and movement of stars were used to create calendars and to navigate across the open seas. Even today, celestial navigation is still used by sailors and pilots as a backup to GPS. Stars have also been a source of inspiration for artists and writers throughout history. The beauty and mystery of the night sky have inspired countless works of art, literature, and music. Artists such as Vincent van Gogh and Edvard Munch were fascinated by the stars and often incorporated them into their paintings. In modern times, stars have also become a source of fascination for the general public. Amateur astronomy has become a popular hobby, with people around the world setting up telescopes and observing the night sky. In addition, space exploration has captured the imaginations of people around the world, with manned missions to the moon and unmanned missions to other planets and beyond. Stars have also been important in the study of the universe's history and evolution. By studying the light from distant stars and galaxies, astronomers can gain insight into the early universe and its formation. This is because light takes time to travel across space, so when we look at distant objects, we are seeing them as they were billions of years ago. The study of stars has also led to important discoveries in physics. For example, the study of white dwarfs and neutron stars has contributed to our understanding of the behavior of matter under extreme conditions. In addition, the study of black holes has led to new insights into the nature of gravity and the structure of spacetime. Cosmic tremors. The universe is full of phenomena that can cause waves and vibrations to propagate through space. These waves and vibrations, known as cosmic waves or cosmic tremors, can provide important insights into the properties and behavior of the universe. One of the most well-known types of cosmic waves is light, which is a form of electromagnetic radiation. Light waves carry information about the properties of stars, galaxies, and other objects in the universe. By studying the light emitted by these objects, astronomers can gain insight into their composition, temperature, and other physical properties. Another type of cosmic wave is gravitational waves, which are ripples in the fabric of spacetime caused by the movement of massive objects. Gravitational waves were first predicted by Albert Einstein's theory of general relativity, and were detected for the first time in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO. Gravitational waves can provide important insights into the behavior of black holes, neutron stars, and other massive objects in the universe. Cosmic rays are another type of cosmic wave, which are high-energy particles that travel through space at nearly the speed of light. Cosmic rays are thought to be produced by supernovae and other high-energy events in the universe. They can provide important insights into the properties of the universe, such as the distribution of matter and the behavior of magnetic fields. In addition to these types of cosmic waves, there are also other types of cosmic tremors, such as acoustic waves and neutrino waves. Acoustic waves are sound waves that propagate through the gas in galaxies and other cosmic structures. Neutrino waves are waves of subatomic particles that can travel through matter with little or no interaction. The study of cosmic waves and cosmic tremors is a rapidly growing field of research. By studying these waves, astronomers can gain insight into the properties and behavior of the universe, such as the distribution of matter and the behavior of magnetic fields. In addition, the study of cosmic waves and tremors can also provide important insights into the fundamental laws of physics, such as the behavior of matter and energy under extreme conditions. One of the most recent and exciting types of cosmic tremors is the detection of fast radio bursts, FRBS, which are brief, intense bursts of radio waves that originate from deep space. FRBS were first detected in 2007, and have since become a subject of intense study among astronomers. The origin of FRBS is still a mystery, but some theories suggest that they may be produced by neutron stars or black holes. Others suggest that they may be signals from extraterrestrial civilizations. The study of FRBS is an exciting area of research, as it has the potential to shed light on some of the most enigmatic objects and phenomena in the universe. Another important type of cosmic wave is the cosmic microwave background, CMB, which is the faint afterglow of the Big Bang. The CMB is a type of electromagnetic radiation that permeates the universe and provides important insights into the early history and evolution of the universe. By studying the properties of the CMB, astronomers can gain insights into the composition and structure of the universe shortly after the Big Bang. In addition to these types of cosmic waves and tremors, there are also other phenomena that can cause vibrations and waves to propagate through the universe. For example, the collision of galaxies can cause shock waves to propagate through intergalactic gas, which can provide important insights into the formation and evolution of galaxies. For example, the collision of galaxies can cause shock waves to propagate through intergalactic gas, which can provide important insights into the formation and evolution of galaxies. Another type of cosmic wave is the gravitational lensing effect, which occurs when the gravity of a massive object, such as a galaxy or a cluster of galaxies, bends and distorts the path of light from a more distant object. This effect was first predicted by Einstein's theory of general relativity, and has since been observed and used to study the properties of massive objects in the universe. In addition, the study of cosmic waves and tremors has led to important discoveries in the field of particle physics. For example, The study of cosmic rays has provided insights into the behavior of subatomic particles under extreme conditions, such as the high energies and magnetic fields found in the universe. Furthermore, the study of cosmic waves and tremors has also led to the development of new technologies that have applications beyond astronomy. For example, the detection of gravitational waves has led to the development of new types of detectors and sensors that can be used in fields such as medicine and engineering. For example, the detection of gravitational waves has led to the development of new types of detectors and sensors that can be used in fields such as medicine and engineering. Finally, the study of cosmic waves and tremors has the potential to answer some of the most fundamental questions about the universe, such as the nature of dark matter and dark energy, and the ultimate fate of the universe. As technology continues to advance, it is likely that new types of cosmic waves and tremors will be discovered, leading to even more exciting discoveries about the universe. The study of magnetic fields in the universe has led to important discoveries in many areas of astrophysics. For example, magnetic fields are thought to play a crucial role in the formation and evolution of galaxies, as well as in the acceleration of cosmic rays. They may also be responsible for the production of some of the most powerful phenomena in the universe, such as gamma-ray bursts and supernovae. In addition, the study of cosmic waves and tremors has led to the development of new technologies that have revolutionized our understanding of the universe. For example, the development of radio telescopes has allowed astronomers to study the properties of cosmic waves such as radio waves, while the development of neutrino detectors has allowed them to study the properties of neutrino waves. Furthermore, the study of cosmic waves and tremors has also provided important insights into the evolution of the universe itself. For example, the study of the cosmic microwave background has allowed astronomers to determine the age, size, and structure of the universe shortly after the Big Bang. For example, the study of the cosmic microwave background has allowed astronomers to determine the age, size, and structure of the universe shortly after the Big Bang. It has also provided important clues about the nature of dark matter and dark energy, which are thought to make up the majority of the universe's mass and energy. Finally, the study of cosmic waves and tremors has the potential to answer some of the most profound questions about the nature of reality itself. For example, the study of gravitational waves may provide insights into the nature of space and time, while the study of neutrino waves may shed light on the behavior of subatomic particles and the fundamental laws of physics. The study of X-rays has led to important discoveries in many areas of astrophysics. For example, X-ray telescopes have allowed astronomers to study the behavior of matter in the extreme environments around black holes and neutron stars. For example, X-ray telescopes have allowed astronomers to study the behavior of matter in the extreme environments around black holes and neutron stars. Radio signals. Radio waves, also known as radio frequency (RF) waves, are a type of electromagnetic radiation that have wavelengths longer than infrared light. They are used for a variety of purposes, including communication, navigation, and astronomy. Radio waves are used for communication in a variety of ways, including radio broadcasting, television broadcasting, and cellular communication. They are also used in radar systems for navigation and in satellite communication for transmitting information over long distances. In addition to their practical applications, radio waves are also used for scientific research in the field of radio astronomy. Radio telescopes are used to study the properties of radio waves emitted by objects in the universe, such as stars, galaxies, and black holes. By studying the properties of radio waves, astronomers can gain insights into the composition, structure, and behavior of these objects. Another important application of radio waves is in the field of remote sensing, which involves using sensors to collect data about the environment from a distance. Remote sensing can be used for a variety of purposes, including weather forecasting, environmental monitoring, and agriculture. Radio waves can also be used for medical imaging, such as in magnetic resonance imaging (MRI) machines. These machines use radio waves and strong magnetic fields to create detailed images of the inside of the body, allowing doctors to diagnose and treat a variety of medical conditions. These machines use radio waves and strong magnetic fields to create detailed images of the inside of the body, allowing doctors to diagnose and treat a variety of medical conditions. However, the use of radio waves is not without its risks. Exposure to high levels of radio waves can cause damage to living tissues, leading to health problems such as cancer. As a result, there are strict regulations governing the use of radio waves in order to protect public health. Radio waves are also used in the field of radio frequency heating, which involves using high-frequency electromagnetic radiation to heat materials. This technology is used in a variety of industrial applications, such as in the production of plastics and in food processing. In addition, radio waves are used for scientific research in the field of plasma physics. Plasma is a state of matter in which atoms are ionized, and it is found in a variety of natural phenomena, such as lightning and the sun's corona. Radio waves are used to study the properties of plasma and to develop new technologies, such as fusion energy. Satellite communication is another important application of radio waves. Satellites orbiting the Earth are used to transmit information over long distances, such as television signals, internet data, and telephone calls. This technology has revolutionized global communication and has made it possible to connect people and businesses across the world in real time. Radio waves are also used for navigation, primarily through the Global Positioning System (GPS). GPS uses radio waves transmitted from satellites to determine the location of a receiver on Earth, allowing for precise navigation and tracking. In addition, radio waves are used for security purposes, such as in radar systems and in military communications. Radar systems use radio waves to detect and track objects, such as aircraft and ships, while military communications rely on secure radio waves to transmit sensitive information. Radar systems use radio waves to detect and track objects, such as aircraft and ships, while military communications rely on secure radio waves to transmit sensitive information. Radio waves are also used in the study of the Earth's atmosphere, particularly in the field of atmospheric science. By studying the properties of radio waves that pass through the atmosphere, Scientists can gain insights into the composition and behavior of the atmosphere, including changes in temperature, pressure, and humidity. Finally, radio waves are used in the search for extraterrestrial life. Scientists use radio telescopes to search for signals from other planets or galaxies that could indicate the presence of intelligent life in the universe. Radio waves are also used in the field of wireless power transfer, which involves transmitting electrical power wirelessly using radio waves. This technology has the potential to revolutionize the way we power devices and equipment, particularly in situations where wires or batteries are impractical or inconvenient. Radio waves are also used for remote sensing of the Earth's surface, particularly in the field of microwave remote sensing. This involves using microwave radio waves to measure various properties of the Earth's surface, such as the amount of vegetation, moisture content, and soil composition. This involves using microwave radio waves to measure various properties of the Earth's surface, such as the amount of vegetation, moisture content, and soil composition. Microwave remote sensing has a wide range of applications, including agriculture, hydrology, and climate monitoring. In addition, radio waves are used in the field of radiotherapy, which involves using high-energy radio waves to treat cancer. This technology is used to destroy cancer cells while minimizing damage to healthy tissue, and has become an important tool in the fight against cancer. Radio waves are also used in the field of space exploration. Spacecraft use radio waves to communicate with Earth and with other spacecraft, and radio telescopes are used to study the properties of objects in the universe, such as pulsars and quasars. Finally, radio waves are used in the field of art, particularly in the creation of electronic music. Radio waves can be manipulated and synthesized to create a wide range of sounds and music, and have become an important tool for musicians and composers. Radio waves are also used in the field of weather forecasting, particularly in the study of atmospheric conditions. Radio waves can be used to measure atmospheric parameters, such as temperature, humidity, and pressure, and to track the movement of weather systems. Radio waves can be used to measure atmospheric parameters, such as temperature, humidity, and pressure, and to track the movement of weather systems. This information is critical for predicting weather patterns and issuing warnings for severe weather events. Another important application of radio waves is in the field of radio frequency identification, (RFID) technology. RFID tags contain small antennas that can be read by radio waves, allowing for the identification and tracking of objects. This technology is used in a variety of industries, including retail, manufacturing, and logistics, to track inventory and improve supply chain management. Radio waves are also used in the field of geology, particularly in the study of subsurface structures. Ground-penetrating radar (GPR) uses radio waves to create images of the subsurface, allowing geologists to map underground features, such as geological formations, archaeological sites, and buried infrastructure. Astronomical observation techniques. Astronomy is the study of celestial objects, including stars, planets, and galaxies. Observing these objects can be a challenging task, as they are often located far away and are difficult to see with the naked eye. To overcome these challenges, astronomers use a variety of techniques and technologies to observe the universe. One of the most common techniques used in astronomy is the use of telescopes. Telescopes are used to collect and focus light from distant objects, allowing astronomers to see them in greater detail. There are several types of telescopes, including refracting telescopes, reflecting telescopes, and radio telescopes. Refracting telescopes use lenses to focus light, while reflecting telescopes use mirrors. Radio telescopes, on the other hand, are used to detect radio waves emitted by celestial objects. They are particularly useful for studying objects that emit little or no visible light, such as pulsars and black holes. Another important technique used in astronomy is spectroscopy. Spectroscopy involves analyzing the light emitted by celestial objects to determine their composition and other physical properties. By analyzing the spectrum of light emitted by a celestial object, astronomers can determine its temperature, chemical composition, and other important characteristics. In addition to telescopes and spectroscopy, astronomers also use other techniques to observe the universe. For example, they use radar to study the surfaces of planets and moons, and they use satellites to study the Earth's atmosphere and to observe objects in space from above the Earth's atmosphere. Astronomers also use computer simulations and models to study the universe. These models are used to simulate the behavior of celestial objects and to test theories about how the universe works. Computer simulations are particularly useful for studying complex systems, such as galaxies and black holes. Finally, astronomers use a variety of ground-based and space-based observatories to study the universe. Ground-based observatories are located on Earth and include telescopes, radar systems, and other equipment. Space-based observatories, on the other hand, are located in space and include telescopes such as the Hubble Space Telescope and the Chandra X-ray Observatory. Photography is another important technique used in astronomy. Astronomical photography involves taking images of celestial objects using specialized cameras and telescopes. These images can reveal important details about the object being studied, including its size, shape, and color. Astronomers also use time-lapse photography to study the movement of celestial objects over time. Interferometry is also an important technique used in astronomy. Interferometry involves combining the signals from multiple telescopes to create a single, high-resolution image. This technique is particularly useful for studying very distant objects, such as quasars and black holes, which are difficult to observe with a single telescope. Astronomers also use gravitational lensing to study the universe. Gravitational lensing involves using the gravitational pull of massive objects, such as galaxies or black holes, to bend and magnify the light from more distant objects. This technique allows astronomers to study objects that would otherwise be too faint to observe. Finally, astronomers use data analysis techniques to study the universe. This involves analyzing large amounts of data collected by telescopes and other instruments to look for patterns and anomalies. These data analysis techniques are particularly useful for studying large-scale structures, such as galaxy clusters and the distribution of dark matter in the universe. Astronomy also involves the study of cosmic rays, which are high-energy particles that travel through space. Cosmic rays can be detected using specialized equipment, such as cosmic ray detectors and particle accelerators. By studying cosmic rays, astronomers can gain insights into the origin and evolution of the universe. Another important technique used in astronomy is astrometry, which involves measuring the positions and movements of celestial objects. Astrometry is particularly useful for studying the motion of stars and planets, and for detecting the presence of extrasolar planets. Astrophysics is another important field of study in astronomy. Astrophysics involves the application of the principles of physics to the study of celestial objects. It includes topics such as stellar structure and evolution, black holes, and the physics of the early universe. Astronomy also involves the study of cosmology, which is the study of the origin, evolution, and structure of the universe. Cosmologists use a variety of techniques to study the universe, including observations of the cosmic microwave background radiation, the study of large-scale structures in the universe, and the use of computer simulations to model the evolution of the universe. Finally, astronomy involves the study of astrobiology, which is the study of the origin, evolution, and distribution of life in the universe. Astrobiologists use a variety of techniques to search for evidence of extraterrestrial life, including the study of exoplanets and the search for biomarkers in the atmospheres of other planets. Astronomy also involves the study of the Sun and other stars. Observing the Sun and other stars can provide important insights into their structure, composition, and behavior. Astronomers study stars using a variety of techniques, including spectroscopy, photometry, and astrometry. Spectroscopy involves analyzing the spectrum of light emitted by a star to determine its composition and temperature. Photometry involves measuring the brightness of a star over time to study its variability and behavior. Astrometry involves measuring the position and motion of a star to study its orbit and properties. Astronomy also involves the study of planetary science, which is the study of the planets and other objects in our solar system. Planetary scientists use a variety of techniques to study these objects, including telescopic observations, spacecraft missions, and laboratory analysis of meteorites and other samples. Astronomy also involves the study of dark matter and dark energy. Dark matter is a mysterious substance that makes up a significant portion of the matter in the universe, but does not interact with light or other forms of electromagnetic radiation. Dark energy is an even more mysterious substance that is believed to be responsible for the accelerating expansion of the universe. Finally, astronomy involves the study of gravitational waves, which are ripples in the fabric of spacetime caused by the motion of massive objects. Gravitational waves were predicted by Einstein's theory of general relativity, and were first detected in 2015. Satellite. Satellites are artificial objects that are placed in orbit around the Earth or other celestial bodies. They are used for a variety of purposes, including communication, navigation, weather forecasting, and scientific research. One of the primary uses of satellites is in communication. Communication satellites are used to transmit a wide range of information, including television broadcasts, telephone calls, and internet data. These satellites are typically placed in geostationary orbit, which means they orbit the Earth at the same rate as the Earth rotates, allowing them to remain fixed in the same position relative to the ground. Satellites are also used for navigation, primarily through the Global Positioning System (GPS). GPS satellites transmit signals that are used by receivers on the ground to determine their location with high precision. GPS is used in a wide range of applications, including aviation, shipping, and land surveying. Satellites are also used for weather forecasting. Weather satellites are equipped with sensors that can detect a wide range of meteorological data, including temperature, humidity, and atmospheric pressure. This data is used to create detailed maps of weather patterns, which are used to make weather forecasts and issue warnings for severe weather events. In addition to their practical applications, satellites are also used for scientific research. Scientific satellites are used to study a wide range of phenomena, including the Earth's atmosphere, oceans, and land surface, as well as the properties of other planets and stars. Satellites are also used to study the effects of climate change and to monitor the health of the Earth's ecosystems. Satellites are launched into orbit using rockets. Once in orbit, they are controlled from the ground using a network of antennas, ground stations, and control centers. Satellites are designed to operate for a specific period of time, after which they may be decommissioned or replaced with newer models. Satellites also play an important role in national security and defense. Military satellites are used for a variety of purposes, including reconnaissance, surveillance, and communication. These satellites are operated by several countries around the world and are critical for monitoring potential threats and maintaining situational awareness. Satellites are also used for remote sensing, which involves the use of sensors on board a satellite to collect data about the Earth's surface and atmosphere. Remote sensing satellites are used for a wide range of applications, including mapping, land use planning, and environmental monitoring. They can be used to detect changes in the Earth's surface, such as deforestation, desertification, and urbanization, and to monitor the health of crops and other vegetation. Space exploration is another important area of application for satellites. Space exploration satellites are used to study other planets, moons, and asteroids in our solar system. They are equipped with a variety of instruments, including cameras, spectrometers, and radar systems, and are used to gather data about the composition, structure, and history of these celestial bodies. Satellites also play a key role in disaster management and response. Emergency response satellites are used to provide communication and navigation capabilities in the event of a natural disaster or other emergency. They are also used to gather data about the disaster, which can be used to guide relief efforts and aid in recovery. Finally, satellites are also used for commercial applications, including satellite television and radio broadcasting, as well as satellite-based internet services. These services rely on communication satellites to transmit data to and from the ground, and have become an important part of modern life for many people around the world. Satellites are also important in the field of agriculture. Agricultural satellites are used to monitor crop health, predict yield, and optimize the use of resources such as water and fertilizer. These satellites gather data on a variety of factors, including temperature, moisture levels, and vegetation growth, which are used to make informed decisions about crop management. Another important application of satellites is in the field of transportation. Satellites are used to track the position and movement of vehicles, ships, and aircraft, helping to optimize transportation routes and improve safety. Satellites are also used to monitor the health of infrastructure such as bridges and highways, and to provide real-time traffic information to drivers. Satellites are also used in the field of environmental monitoring. Environmental satellites are used to track changes in the Earth's climate and environment, including the melting of polar ice caps, the depletion of ozone, and the growth of urban areas. These satellites are equipped with sophisticated sensors that can detect changes in the Earth's atmosphere, land surface, and oceans, and are used to provide valuable data for climate models and environmental policy. In addition to their practical applications, satellites also have cultural significance. Satellites have enabled people around the world to communicate and share information like never before, breaking down barriers of distance and language. Satellites have also enabled us to see our planet from a new perspective, providing stunning images of our world and the universe beyond. Satellites are also important for disaster response and recovery efforts. In the aftermath of natural disasters such as earthquakes, hurricanes, and tsunamis, satellites are used to provide critical information about the affected areas, including mapping the extent of the damage and identifying areas in need of assistance. This information is used to guide relief efforts, including the delivery of food, water, and medical supplies to affected populations. In addition, satellites are used to monitor and predict natural disasters, such as hurricanes and flooding. These satellites collect data on a variety of factors, including temperature, moisture, and wind patterns, which can be used to create models to predict the path and intensity of these events. This information is used to issue timely warnings and evacuate populations in the affected areas. Another important use of satellites is in the field of astronomy. Astronomical satellites are used to observe the universe beyond our solar system, including distant galaxies and black holes. These satellites are equipped with sensitive instruments that can detect a wide range of electromagnetic radiation, including radio waves, X-rays, and gamma rays. This data is used to study the properties of celestial objects and to understand the nature and evolution of the universe. Finally, satellites are important for global development efforts. Satellite data is used to inform development policies and programs, including those related to agriculture, water management, and urban planning.